Hi, welcome to a product test and review by Robojax. In this video we are going to test this boost converter module that is sold on Amazon, eBay and AliExpress, and they claim that it can handle up to 600 watt load with the input voltage of from 10 to 36 volts and the output voltage up to 80 volts. We are going to test the input, output voltage and load, and we will also show you some thermal image to see which part is getting hot. Let's get started with this. Volts, 78, 80 volts, 90 volts. As you can see, it's burning and the device just died. It should have not allowed me to go above 80. Let me show you how you can open it. This is the module. It seems very solid built, and the heatsink is attached with 4 screws with these insulated handoffs. We have 2 terminals here at the input which have been labeled as in plus and in minus, and 2 terminals for the output. In order to open and detach this piece from this, we need to desolder and remove the solder from these pins. This is for the MOSFET and this is for the diode, and then which I have done that, and then remove these 4 screws. Here are the 2 components which have been removed. The chip on this side is 072N10N. Here is a data sheet. It has VDS as drain source voltage of 100 volts and resistance of drain source is 7.2 milliohm, and the drain current is 80 amperes. So this is way capable of handling the current. The other one that we have is this one. This is the 2100 B2100G, and here it is. This is a Schottky barrier rectifier. This is between the load and this device. Let me explain now the module. This is the input. It has been labeled as N minus and N plus. You will connect the input at this point, and the output is labeled here plus minus out. The input also has a small adapter type connector which is not suitable for this application, because for 10 ampere and 15 ampere this adapter connector is not right, but they've used it. On the path from the positive, it goes to this 15 ampere fuse. Then we have the adjust for current. This is I adjust, current adjust, and this is for voltage adjustment. We have input capacitor here. The voltage is 63 volts, 1000 microfarad, and here 2 capacitors at the output with a voltage of 100 volts, because the output can go up to 80 volts, and these are both 470 microfarads. This transistor is a Darlington fast switch NPN transistor. There is a data sheet for it, BUS806, and it can handle maximum of 8 ampere. This is not the output stage. And here we have the current mode pulse width modulation controller, and this is the data sheet UC3842A. This is the one that is used. As you can see, current mode pulse width modulation, and we have this surface mount device. I will provide you the link for this. And this is LM358 low power dual operational amplifier. This chip, and this is a data sheet. I will provide you the link in case if you want to have a look at it. These 2 that are at this location and this location, these two. This one is the 072N10. This is a power MOSFET, the main switch. This can handle, this is a data sheet from Infineon. Maximum current it can handle is 80 ampere, and pay attention here, the drain source voltage is, I will provide you the link for this. This is a Schottky power rectifier diode, that's the output stage. Here is a data sheet. Two diodes have been connected, cathodes together, and the anodes are separate. The model is 20100 CT. So this can handle 20 ampere and 100 volts. And if you pay attention, pin 2 is common, so anode is pin 1 and 3. The pin is connected to the output to the positive mode. This is now in diode mode. If I put the positive on this side, the negative at the middle, you will see the forward voltage is 0.27 volts, and the same way for the other diode. Width is 63 millimeter. The length is 85 millimeter, and the depth is 61.5 millimeter. To quickly remind you, the basic boost converter configuration is like this. You have input voltage, you have input capacitor and output capacitor. This is the output, and we have inductor and a switch. The switch is a MOSFET which will be turned on and off very fast, and we have a diode here that prevents when the switch is on. This will prevent the discharge of this capacitor. But this is the MOSFET that we have, and that's the inductor. Exactly that. The exact configuration have been used here. I've drawn this partial schematic diagram for this. Input passes through 15 ampere fuse, and then we have 1000 microfarad capacitor at the input. This is a big inductor. This inductor and a big MOSFET 072N10N. This is this MOSFET which goes in here, and this resistor is between the source. This pin is called drain. It's connected to the positive. The source is connected through this shunt resistor to the ground, which is this shunt resistor. This wire is a resistor, very low resistance, that when current passes, it could be around 0.01 or 1 milliohm, and it creates some voltage across it, and the voltage is measured, and then current mode amplifier, and then current mode controller will decide to control the output voltage. And these two diodes are part of one package of 2100, which is this one. The two pins are here, the three pins are here, and this is directly connected from the middle pin to the output. And this is the output pin, the positive on this side. And then we have two 470 microfarad capacitors, 100 volt operating voltage. These two. The rest were very was time consuming, and it's not necessary, otherwise I would have drawn it for you. This is the electronic load DL3031, and these are the two terminals that from the circuit will be connected in here, and we will see the voltage here and the current. Let's first check the input voltage, and this is the output voltage. This is the output voltage. I've set it to 15 volts, and you see the input voltage is 11 volts. Let's reduce it and see at what voltage it does not produce the output. So I'm reducing this voltage now. Pay attention also here. As you can see, the voltage suddenly dropped. So at 10 volts it doesn't work. Now 10.8. So this particular model at 10.8 volts will give you the output voltage. Let me go to the maximum voltage. As you can see, voltage is increasing. Let's just go 2 ampere, test it. It doesn't work even with 2 ampere, as you can see. I'm increasing the input voltage and the output changes. So the output voltage is not stable with 10 volts. You see, it shows 71. Let's make it 12 volts. So I'm starting with 12 volts. Output voltage, as you can see, output voltage goes to 80 volts. There's a problem. If you rotate this, it will increase. From my previous experience, I know that if I increase this voltage, the MOSFET will die. Here is the video for that. 90 volts. As you can see, it's burning, and the device just died because it allowed. Then I purchased this one. I waited 2 months or more, about 1 or 2 months to get this one. Make sure to never go above 80 volts at the output. Now input is 12 volts, output 24 volts. Let's go 10 ampere. As soon as I go 10 ampere, now the input current is 14 amp and the voltage has dropped. So this could be due to the current limitation. So let me increase the current. When I rotate this, the input current increases, and that is the maximum we are getting. Input is 15.2 ampere, 15.6 ampere, eight ampere. So when you see that 19, that is the current limit. Input is now 16 ampere. We are going beyond the limit. What input 15.6 ampere. So we have set input now at the maximum. (15.6 ampere). So 7 amp. If I go 8 amp, it will not work. You see the voltage has dropped. 18.1 ampere at the input. Now let me show you the thermal image. (64 degrees). And the hot spot is this spot that I'm touching. This is the hottest spot, the connector and the connector of the fuse. and the temperature is it was 138 degrees, very hot, 8 ampere, because the input must be below 15 ampere. Now input is 12 volts, output 36 volts, and as you can see the output is now increased, so 8 ampere will not be acceptable, because if I click it, already I see 20 ampere was the input current, so I have to reduce this with input of 15 ampere limit. When you get 12 volts and 15, you get 180 watt at the input, so I have to watch out for 180 watt power at the output. Now if I want to get 36, so 180 divided by 36, 5 ampere we can get. Let's try it. I've set it to 5 ampere. Let's turn it on. Output is not 36, it's fluctuating. Input current is 16.3 ampere. $18 ampere. The input is now 18 ampere. And this one makes a little noise. This is getting hot. It's 200 degrees. Input current 14.5 ampere, output 4 ampere, as you can see, at 36 volts. Reduce it. Now the input, this is 3 amp, now the input current is 10.3 ampere. It's 50 volts. Let's go with 3 ampere. We know 3 ampere is way above the limit. Input current is now 15.1 ampere at 12 volts. There is a noise. Let me put the microphone closer so you can hear the noise. So the voltage is very bad. It cannot handle that current. Current input is setting. The output 2 ampere cannot handle it. You see, when I turn this off, it goes 50. It becomes 0.4 volts drop here. So if I go with the 3 amp, you will see it will significantly drop, so it doesn't work. You will not be able to get 3 amp. So only 2 amp if you accept with 0.4 volts drop. So output only 2 ampere at 50 volts. With 12 volts input, output 60 ampere. Let's put it at 2 ampere output. 0.4 volts drop, 0.35 volts voltage drop, still acceptable. Input current is 12 ampere. I increase it with 3, the voltage dropped, so it doesn't go with the maximum current is setting here. Now input is 12 volts, output 80 volts. Let's go with 2 ampere. Doesn't work. The current is set to the maximum. Remember, I've not limited the current, so it doesn't work. Right now input current is 16.4 ampere, and so let's go 1.6, still doesn't work. 1.5, 1.4, turn it off. 80, turn it on. 1.3 is 78.8, so it's already 1.2. It's unacceptable. .2. Now 0.5 volts drop with 1 ampere, so you can get 80 volts, 1 ampere at the output. Input current is 8.1 ampere. I've spent quite some time working on this module, testing it and finding the information and creating video so you can decide about it. The least that you can do for me is to hit the subscribe button and leave the notification on. Thank you. Now I'm testing with 15 volts input and 24 volts at the output. Let's go 5 ampere. Five ampere seems okay. Input current is 8.5 ampere. Let's go for 6. So 0.2 volts drop, still okay. 10.2 ampere at the input. So 7 ampere at the input. 12.2 ampere at the input. The 7 ampere is the output. 8 ampere output. Input is 14 ampere. Let's do the calculation first. The input 14.1 ampere times 15, 211.5 watts, 189 watts, divided by 89%, 89.6% efficiency, 36 volt at the output. 7 ampere doesn't work, so let's reduce it. Input current is 19.7 ampere. Now 5 ampere, 13.9 ampere at the input. This is 0.3 volts drop or 0.22 volts drop, acceptable. Now 15 volts the input, 50 volts the output. 5 ampere, voltage drop significantly, doesn't work. Let's reduce it to 4 amp. Still the voltage is not 50. 3 amp. Now it's 0.4 volts, let's accept that. Input is 11.6 ampere times 15, 124 watts store in A, and output is 3 times 49.6. that is the output, divided by the input power, 85.5, that's the efficiency, acceptable, pass. 15 volts input, 60 output. Let's go with 3 amp. Doesn't work, significant drop. .9, 2.8. So 2 ampere works fine. Input is 9 ampere. Input is now 15 volts, output 80 volts. 2 ampere, I'm sure it will not work. Drop significantly. Let's make it 1 amp. 1 ampere is acceptable. Let's see the efficiency. 6.3 ampere input times 15, 94.5 watts at the input, The output is 1 times 80, that's 80 watt, divided by, recall A, 84.6% efficiency. Now let's start with 24 volts at the input, and the output is now setting the next higher voltage, 36. Let's go with 6 ampere. Ampere works good. Let's increase it. 7 ampere is good. 8 ampere, 0.3 volts drop, still acceptable. Let's make it 9. 0.4. Let's make it 10. 10 ampere is output with 36 volts, and input is 16 ampere, 92.7% efficiency. 24 volts at the input, 50 at the output. Let's 9. The voltage has dropped 3 volts, not acceptable. 9 will not work. 8 is still not working because the voltage has dropped more than 1 volt. 7 still not acceptable because it's 0.9 volts. 6 makes it 0.8 volts. 5 still doesn't work. So 4 is acceptable because it's 49.7 amp. Pass. Let's go with the 64 ampere. Acceptable, but it makes some noise. 11.3 ampere at the input, 87.3% efficiency. 24 volts at the input, 80 volts at the output. Let's go with 4. 3 volts drop, unacceptable. 78. Now this is 1.8 volts drop, unacceptable. 2 ampere, acceptable. 0.3 volts drop because of the current limitation. Now the input is 7.6 ampere, 7.6 times 24. That is the input power, 182.4. The output is 159.6, 159.6 divided by the input power, 87.5 watts. Very hot. It's almost burning my hand. Now we have 36 volts at the input, 50 volts at the output, 3 ampere at the input, 2.9. Let me increase the power. 2, 3, that's 4, 5, 6, 7 ampere, 10.2 ampere at the input. So we have 10.2 ampere, 36 volts, 95% efficiency. Now 36 volts input, and we have 60 volts at the output. 9 ampere doesn't work because it's limiting it. 8, 6 ampere, 7 amp, 60 pass. 36 volts input, 80 at the output. Let's go with 7. Doesn't work. Automatically protection kicks in. 6 ampere doesn't work. 5, 4 ampere works. So we got 4 ampere at 80 volts. Now this is unacceptable because it's 0.8 volts drop. Less than 5 will not be acceptable, so 3 is good because this is 0.5. Now input current is 7.2 amp times 36, 259.2 watts, and the output 238.7, 238.7 divided by 92% efficiency. Volts, I want to see if I can get 36 volts. These voltages are very close to each other. 6 ampere. With 6 ampere, input is 7.4 amp. With 7 ampere as the output, 8.6 ampere at the input. With 8 ampere at the input, we got 9.9 ampere at the input. With 9 at the input, we are getting 11.1 ampere at the, with 9 ampere at the output, we are getting 11.1 at the input. 10 ampere at the output, we are getting 12.4 ampere at the input. You see the total power, 357 watt. Now 11 ampere at the output and 13.6 ampere at the input. Conclusion. This module is labeled falsely as 600 watt. Under no circumstance I was able to get 600 watt from this. The quality of the path on the PCB is very low. It cannot handle the input current. It might burn very easily. If you have already purchased it, try to put some extra wire on the path on the PCB so it cannot burn easily, wire or solder so it can handle all the current. Generally do not recommend this product because it's not trustworthy and the quality is very low. I would like to sincerely thank the following people who have supported me via Patreon. Thank you for watching. This was the review and test of this so-called 600 watt power module. If you learned something and found this useful, please thumb up. Please subscribe so you can get updates of my upcoming videos. If you have not subscribed so far, if you have comment or question, post it in the comment section below. So this is a very bad design. In case if you have already bought this, make sure to solder a wire from here to here and also another wire from here to this point. This is very thick, but this is not enough. So you have to put a wire from this point directly touching the pin to this point.